Okay, good morning, everybody. We're really glad you're joining us today, and we look forward to having a blessed time with you all together as we learn from our speaker today. And I believe he's going to do justice to the topic today. So without taking much of our time, we'll go straight into the agenda for today. Okay, so the agenda for today is going to be, we are already accepting participants for today. So, and we're using this opportunity to welcome all of you here. Thank you so much for joining us. So the most important thing is what we're doing now. We're going through the agenda, and that's the next thing. That's from 10 a.m. to 10:15 a.m. So then the next one will be that we'll introduce our speaker. Then we'll give the floor to the speaker who is going to take like 1.5 hours to take us through the topic for today. Then we'll take the Q&A, that's the questions, then he will be able to answer our questions. So, but all depends on the time that is, how well you can use this time well. So then that will be the vote of thanks. So I would like to introduce my senator of Abuja, our user group, and our ladies Abuja. So we have other co-coordinators, but unfortunately we don't have much of them around today. So, but nonetheless, we're going on. So the next thing is now introducing our speaker. So I'm going to go off the video to allow you to focus more on our speaker. So our speaker today is Oguyemi Olakunle Joshua. So there's a great man that I've met, and Olakunle is a seasoned data analyst, an R instructor with a global impact on young people across the world. He is also the founder of Tag NG, a leadership organization poised to adding fragrance to the lives of young people in the area of data science, leadership, and entrepreneurship. He holds a master's degree in forest biometrics and information systems from the Premier University of Ibadan in Nigeria here. He is also the author of the first book on R in Nigeria with the title Basic Statistics for Undergraduate Students Using R. Personally, I've learned a lot from this guy. Is young, vibrant, and is somebody who motivates you a lot. It's the first impression matters a lot, and that's something that I've always hold on to. He's young, down to earth, and somebody lovely that you will always want to. I always learn a lot from him every day. The motivation he gives on LinkedIn, WhatsApp, and the rest. And most importantly, he carries along the young folks. He is very good with that, and that I will give to him. So I have a lot that I could have said about our speaker. I'm not going to take much of our time there. I would like to call on Joshua to take the floor now. Joshua, are you ready?
Yeah.
Okay, thank you so much for honoring us with your presence today. And so I'll stop sharing. Okay, so you can go ahead and share.
Okay. Good.
Thank you.
Okay. I would also like to, okay. I'll take the recording from you.
Yes, we can hear you. You can go ahead now.
All right. Okay, good. Good morning, everyone. So good to be with us today. She has said much about me, but many of it something I was laughing when she was talking, but I want to appreciate you for this privilege. I'm always happy for a kind of privilege like this because it really gives me the opportunity to do what I'm actually here on earth for, impacting the life of people. And so on that note, I want to say a big thank you to you. So straight to what we have for today, data analysis using R. I have it in mind to share with us a brief story before we go into this topic we have for today. Oftentimes, people do look at me and they get confused, you know, and the reason why they get confused is each time I tell them I have my background in forestry, they're always surprised. "Oh, then what are you doing with our? What do you do with our?" And then I laughed and I told them a brief story about myself, how I had wanted to study the engineering and I had to, resort to studying forestry. And then one thing I've learned so far from that particular experience is this: there is no course that is useless. Every course you find yourself is important. It depends on what you make out of the course. So I decided on the exact path I was going to follow in that particular profession. And to the glory of God, I'm happy I made such a decision today. So as regard my journey into R, I started learning R when I was doing my master's program at the University of Ibadan. And it was just like a garden like this. But I picked up an interest, and since then, I've always been doing something, learning on R, attending forums like this to learn new things on R. And today, I bless God for where I am. So let's quickly move straight into what we have for today. I've decided to make it very simple, looking at the time I've been allotted. So I have a code already prepared, and then I walk us through the codes within the limited time I have. So when you open this is a typical Arrow Studio platform. I want to believe we have some of us here who are new to R, and that is why I've decided to do everything possible to break this thing down, so everyone could at least take home something from this training today. So we have the Arrow Studio, which is an IDE of the base R. Many of us might not know the base R. Time would not pass. Okay, I can quickly open that for us. This is what I mean by the base R. Okay, good. So this is what I mean by base R. Please, can you see my screen?
Yes.
Okay, so basically this is what I started with. I started learning R with this. So this is the console. And then for me to bring in the editor pane where I will write my code, I just go to file and I say new script. Then I have it here. And most times I like to tile it. To ensure that all these spaces are well utilized. So I go to Windows and I tile. We have basically two types of tiling, the horizontal tiling and the vertical tiling. So I'm familiar. I love this vertical tiling. And then our console by default, we have all these statements that we have. So the first thing I used to teach people to do is how to clear your console. So to clear your console, you press Control and L. So Control L, clear the console. So you write your code on the editor and you see the result on the console. So this is where we started. Using R as a basic calculator, I can say 2 plus 2. Then to run my line of code there, I press Control and then I put R, Control plus R. So I have the result displayed on the console. So telling me that 2 plus 2 is 4. So in a situation where I have 2 and I just put plus, then I run this, you are going to see what will happen. But let me explain this. On the console, you would see, having printed out the result, you will see that greater than sign, telling us there is no error. Arrow is set to receive another command. But in the case where I press 2 plus and then I press Ctrl R, you're going to put a plus sign. This plus sign means that the code is incomplete. That's what it means. It is not giving us the greater than sign, telling us arrow is ready for another command. In this case, arrow is not ready for another command. Arrow expects us to go back and fix the code where we have the error. So if I go back and I put 2 plus 3, it's still going to give us another issue because it stops initially at the level of 4. So what I'm doing here is assuming that this is 4 plus 3. as against the 2 plus 3 that I have here. So I can do this again, and then I have 2 plus 3 to give me 5, and then I can continue and say 4 plus 4, and then I run it Control R, it gives me 8. I'm back to the way it is meant to run. So this is the base R I was talking about when I said R Studio is an IDE of the base R. So I'll move away from here. Everything we can do on R Studio we can also do here. But people complain that the platform is boring, and then the Arrow Core development team came up with this concept of Arrow Studio. So when you open the Arrow Studio, this is the first thing you are going to see. So we call them panes. In the base R I just showed you, we just have 2 panes. The panes are just the editor pane and the console pane. But for Arrow Studio, we have at default, we have just 3 panes. Those 3 panes have some sub panes inside. We have the console, terminal jobs. We have another pane for environment, history, connection, and tutorial. I added this. You can add as many sub panes that you want. I have files, plot, package, helps, and view. So this is the default statement I showed you the other time on the base R. So to clear it, it is still going to be that same code that will press the Control plus L. So Control L will automatically help in clearing your console. So how do we bring in our editor pane? So we could just start up with what we have. I go to File. We'll go to File. Let me minimize everything I have here. We'll go to File and bring it down. Okay, good. So we go to File, and then we say New File. We say Arrow Script. So we have it there. So just like we were doing before, we say 2 plus 2, we run it, we have 4. So in this place now, to run your line of code, you're going to use a different thing entirely. In the base R, I said we would use Control plus R, but here we'll use Control plus Enter. And you could also see the run option here, and you see underneath it, we have run the current line or selection, and we'll see the shortcut Control plus Enter. So I would advise we'll keep Control and Enter. So we have that as 5. So the console is still filled with that default statement. So we can clear everything we have on our console by pressing Control plus L. So automatically our panes, we now have 4 panes. We now have 4 panes. So these panes, depending on how, depending on what you like, the panes can be rearranged. What I mean by rearranged is, if I don't know, time might not permit, I would have loved to talk about all the menu options that we have here: the file, the edit, the code, the view, the plot, the section, the build, the debug, profile tools, and help. But let's quickly talk about how you can rearrange this. Doing this to tell you how flexible Arrow Studio can be. So I go to view, so I go to panes, and then we'll go to pane layout. So with this pane layout, you can just change, you can rearrange. To suit your taste, I can choose to bring my console. I can choose to bring my console here, and then I have my source beneath. So when I'm done with it, I just say apply. Let me take this up again. So when I'm done, I scroll down, and then I say apply. So immediately when I applied, let me press OK. You would see that now I can write my code there, 2 plus 2 plus 3, and then I see the result up. So you can do anything. You can bring the console to the place where we have the environment. You can just do anything. Everything is possible with this particular software. So let me clear the console again, clear what we have here, and then go back again and rearrange what we have done. The view, then I go to panes, the pane layout again. I change this to our source, and then it gets back to where we are in minds. And then scroll down, apply, and then you click on OK. So that is that about that. And there is something I always love to do. I don't know. I'm going to talk about that briefly. I always love to change the background color. So I do that by going to global options, having gone to tools, then I just go to appearance, and then I love cobalt, then I say this, apply, and then I said okay. So you can just choose any kind of color you want when working with this particular software. So please let me ask this question. Are we familiar? Are we cool with this, or should I take it back to the whites before we start off with what we have for today?
I
We
think
are cool with
that's
that.
that's a good question. Are we all okay with this? The background?
The background is better. It's nice.
Yes, it's okay this way.
Okay. Now, having agreed that this is okay, I already have a code I've prepared. I'm going to open the code. So, I mean, just to work with this short time I have, Abuja ladies. Okay. So it's a ML bench. Okay, I'm going to do that. So we have talked about Arrow Studio, the installation. It is very easy to install. So to install Arrow Studio, you can just go to www.arrowstudio.com. So you go to the aspect of resources, you download it. For it to start working effectively, you have to ensure that you have the base Arrow. So you download the base Arrow first, and then you go to download the Arrow Studio, talking about installation and setup. And then we'll go to introduction to Arrow Basics. Talking about Arrow Basics here, I will talk about variable. Let me do everything as fast as I can. Talking about variable, let's talk about data types and data operators, and then we go from there to how we can do some few things, learn more about the environment, the concept of environment. All right. So the first thing I want to introduce to us is this concept of data and variable. So we are learning data analysis using Arrow, and I'm sure we all understand what we mean by data. Data are just like information. So it is possible for me to gather data about the age of people at this particular training. So that's the data. So the age is now the variable. You understand? So the age is the variable. The data are just the numeric value I have. So using that example, how do we learn how to create variable on Arrow? So let's talk about the types of variable we have. We have numeric, and categorical variable. We have numeric and categorical variable. Let's go to a bit of theory. Under numeric, we have the discrete, continuous, and under categorical, we have ordinal. So I will explain the concept of discrete. This is what I mean by discrete. An example is when I roll a die. Rolling dice. So it is possible I roll this die 6 times, but it is not possible I roll the die 6.5 times. Do you understand? So such an example is an example of discrete, values that do not have any kind of float numbers with it. So when I mean discrete, it is just a whole number. Let me use that word. So continuous is that value that has some kind of float values with it, float numbers. When I mean continuous, this is what I mean. It is possible it has some kind of float values, 5.55555. These are example of continuous numeric variables. It could be 5.01, it could be 5.02. So you can check the weight of somebody, the weight, and it could weigh, that person could weigh 33.6 kg. You know, these are example of continuous variables. So under the categorical variable, I said we have the nominal and the ordinal. Nominal has no reason for ordering. The ordinal has a whole good reasons for ordering. When we proceed, we'll see some examples. Let me give us an example for this particular ordinal. Imagine you are doing a research where you have to state the level of temperature in a particular environment. So you could have low, you could have medium, and you could have high. So this is an example of something that can be ordered. So what I mean here is that there is a difference between a temperature at the low region. We have a difference again between the temperature at the medium region, temperature at the high region. We will learn how to make our understand when we have a variable that is nominal and when we have a variable again that is ordinal, categorical in nature. So let's proceed from there and talk about how we can assign variable in R. Please, are we following? If I'm too fast, you can just tell me to calm down, please. I'm just trying to work with time because we have a lot to cover. Are we following?
Yes, sir.
Okay, so the first way we're going to learn to create a variable is using the less than assignment operators. We have we'll still deal with that data operators and now we have what we call the assignment. Yes, the assignment operators. So the assignment operators, we have the less than assignment operator, we have the greater than assignment operator, we have the equal to. What do I mean by that? Let me clear all this. We give an example of age. Imagine I just picked at random 5 people from this particular class and I asked questions as regard their age. And then I say age is the variable name. And then let's learn how to use the less than. You put the less than in this way and you put the hyphen. And then let's say the first person's age is 12 years old. I don't know. We don't have anybody who's 12 years old. Let me just say 19 years old. And so when I do this, we have learned that to run a line of code, we press Ctrl Enter. So when I press Ctrl Enter, look at what will happen at the level of the global environment. And then I will quickly talk about this concept of environments and move away from there. So when I run this, what do we have on the global environment? We now have values. We have age and we have what? 19. Is that taken? So having done this, what we now have on the global environment means that we can now access age as a variable. When we run age, it can actually display what it is storing, the data we have inside of it. So it is quite different from me now coming on this particular place and just press Kunle. It will tell me, come on, object Kunle not found. Why? Because it is not yet stored as a variable. How do that? Let's go and learn a bit of this. We'll see search. So this is before it will bring out any kind of result. The first point of call that arrow will search for is the global environment. So the global environment is where you store variables temporarily on R. So you search on the global environment, it could not find Kunle. It went from global environment to Tools Arrow Studio. It couldn't find. It keeps searching until it gets to package base. It couldn't find, and then it brings out this error term, object Kunle not found. So that is the importance. That is why it is important we create a variable, and that is what we're learning now. So imagine I said I picked at random 5 people. Imagine I have 19 and then I say comma. Imagine I am imputing for the rest 5 people, and another person is 25, the next person is 30, the next person is 31, and the next person is like 22. If I run this now, I'm going to have an error. So why do we have the error? We didn't have the error when it was just one person. So when we have more than one data that we are, merging into a variable, putting inside a variable, then we have to use the concept of vector. We have to vectorize them. We have to combine them. We have to concatenate. All these words are still the same thing. So we introduce the vector function, the C to begin it. We open the bracket and we'll close the bracket. By default, Arrow Studio, that is one of the advantages of Arrow Studio to the base R. When you open a bracket, automatically it helps you to close the bracket. So in that way, it's with Arrow Studio, error is greatly minimized. Error is greatly minimized. So if I run this now, then everything is well programmed now as age having 5 data inside it, 19, 25, 30, 31, and 22. And when you look at the global environment gives us information, a lot of very, very insightful information. You could see under age, we have age as numeric and it has 96 bytes. So I have, let me check. Yes, I have this particular thing, but time will not permit me to go through this particular thing. We see, this is one of the reasons why R is very good compared to other softwares. We have R as a programming and a statistical language. It is good for data analysis and visualization. We're learning that today. It is simple and easy to learn. It is free and open source. You download it free of charge without having to pay any kind of thing. We have learned about the environment setup, how we can download it, rstudio.com, and then to download the base R, you can easily go to cran.r-project.org. And then we have seen this particular platform. So I'm just moving straight to where we have, okay, we talked about variables. That is where we are now. So I give an example, and this is the sweet test analogy I always love to use when training people. So you could see this is data standing outside on its own, and this is variable like a container. So most times when I define variable as a housing for data. So if you don't want to expose your data, you keep it in the variable. And anytime you need the data, you call the variable. That's what we do in R. So look at the definition I use for variable are nothing but reserved memory location to store values. This means that when you create a variable, you reserve a space in the memory. This is what's going on here. When you go to age, you see that the class of age is numeric and it's consuming how many space on your memory? 96 bytes. So the first information that thing is giving us at the level of global environment is the class of that age. So you use the function class to get that. It's a class, and then the argument that comes into the class function is the variable name. Class of age, it tells us that that particular variable is of the class numeric. So you could see again, you see it here, NUM. And now look at what we have here. We have the square bracket and we have the position 1, range to 5. And then we have the square bracket closed. Then we have the data that we have there. So let's talk about the square bracket. The concept of the square bracket, anytime you hear square bracket, majorly what should come to your mind should be the concept of indexing. So I have age. What this 1 to 5 is saying is talking about the position. So the object, the data in position 1 is 19, the data in position 2 is 25, position 3, 30, position 31, position 4, 31, position 5, 22. So let's take, for instance, that your interest is in the guy in position 3. That is the person whose age is 30. How do you index that particular guy alone? So that is what this square bracket is trying to tell you. So you're going to do that with respect to the variable, and then you put square bracket. The guy with age 30 is in position 3. So you put 3 and then you run it. So you have 30 alone. So imagine you want to see the whole output, the whole range of age. So you say 1, just like what we have on the global environment. So you use this special operator, full colon, that is 1 range to 5. And then you run it. It prints out the entire thing that we have here. So that is one of the information the global environment is trying to tell us. So again, you could easily say you are interested in getting age from position 3 to 4. You will have it. And then you can say you want to exclude a particular age. You can say age, exclude the age in position 1. If you run this, you see the result. Control Enter. Okay, my system is a bit slow. You could see, so 19 is excluded. 19 is that particular age in position 1. So you could just, these are some of the possibilities you can do. You can say age, you can extract out the age in position 4, which is 31, and then you have it left here. So it is possible, for instance, having done this survey, I mean, asking for the age of 5 people in this particular class. Let's take, for instance, that guy in position 3 came back and said, sorry, you made a mistake. I gave you the wrong answer. My age is not 30. I am just 29. So how do I change it? Easily, I can just, and that is where we learn the concept of reassigning. What I'm doing now is the concept of reassigning, building on the concept of indexing. So I would say I'm still giving it age. I'm not changing the variable name. I'm still calling it age. So we're learning, let me put it here, the concept of reassigning, and again, I can also call it overwriting. So we have the variable initially being referred to as age, and here we have the error, 30. So we are creating a new variable again that will be called age, and then we'll make corrections. So this guy is no longer 30, is now 29. So what do? Then I'll say age. I'll say, I can easily just come up and say age. Look at, let's learn the concept of reassigning. I'll say age, and then that guy is in position 3. And then I will say, please, this guy in position 3 says he's no longer 30, he's now 29. Then I run it. And when you look at the global environment, you see it is already changed, programmed to what? To 29. So that's that about how you can create variable and how you can do some kind of play around indexing and some information you can also get from result displayed on the global environment. So that is how you can create variable using the less than assignment operator. You can also do that by creating variable with, okay, ask your question.
Yes, sir. Assignment operator, can we also use it as equals to sign?
Yes, that's where I'm going. You know, I gave us 3 of them initially. I said we have 3 of them. The less than assignment operator, we have the greater than assignment operator, and we have the equal to assignment operator. So I'm just going to use the 3 of them as an example, and then we'll proceed. Is that okay? Is that okay?
Okay, sir.
Yeah.
Okay, so we have age.
Okay,
let's
sir.
take let's take for instance, we are creating something that is categorical in nature, something character. So just again, random sample. I just meet with 5 people in the class and I'm asking for their names. So I'm creating a variable. I'm saying arrow names. I'm calling it arrow names in this way. Let me say arrow names. Now we're using the greater than assignment operator. The only difference is just in the position of the variable name. In this case, when we're using greater than assignment operator, the variable name will be on the right-hand side and the data we are storing in it will be on the left-hand side. So in this case, we understood the concept of combination, the concept of vector. This is the way it's going to be. So you put the hyphen and you put the greater than assignment operator. So what are we combining? Now we are combining names of people that we have in this particular class. So since it is character, so character in R will be quoted. Same thing with other softwares like Python. So you have to get it quoted. So let's say the first person is Joke. I'm just giving a random name. You separate it with comma as we did for that of numeric. So say Joke. I like to use my name only. And then let's just say Dio. Let's say Shola. There are 5. Let's say Dupe. And then let's run this. So when you look at the global environment, we have successfully created a variable called arrow underscore names. And the class of that variable is character. So you know how you can index Joke alone now. So you can check that by saying class, what's the variable? Arrow underscore names. So by default, Arrow Studio will suggest it for you. That's the advantage. So I don't need to type all long, I just press enter. So I run this, it tells me this of the class character. So how do I index Joke alone, for instance? I already know that. So I'll just say arrow underscore names, and then I put square bracket. Joke is in what position? Position 1. Then I run it. So I have Joke alone. That's that about that. So we can also create, again, we can create a variable using the equal to assignment operator like the question you raised. So how do we do that? We already have a variable created for age. We already have a variable created for the names. Let's create a variable for location where we are connecting from. I'm aware some people are connecting. I have one of my students connecting from Canada. So let's just say location, loc, LOC. Let's say R, and that's called loc. And then I just put equal to, very simple. I put equal to, and then I combine. Where are you connecting from? Somebody's connecting from Canada, CN or CND. Let's just use some short code. I have somebody connecting from NJR, Nigeria, for instance. The next person is also connecting from Nigeria. Let's say we have somebody connecting from Ukraine, UKR. Let's say we now have my friend, let's say connecting from Germany. Let's say GRM, like that. I'm just using. So I run this, and then we have successfully programmed arrow underscore location. Do you understand it now? Hello, do you understand?
Yes, sir. Yes, sir.
Yes.
Okay,
Yes.
good. So
Do I
this is
have any question or concerns at this point?
okay, good. If we have questions at this point, we can quickly raise it. In the absence of no question, am I to assume, am I to
Yes.
believe that we all understand?
You are good to go, sir.
Okay, beautiful. So having done this, we have learned some very, very important things. We have learned the concept of variable, how to create variable using the less than, the greater than, and the equal to assignment operator. There are many ways we can do this, and this is one of the beautiful things about data scientists and data analysts. For instance, I can decide to do something now. I can say probably I give I give you a test and I graded everybody, and then I call that variable scores. And then I say scores. Look at what I'm going to do. I say scores. Look at another new way. Another way I can create variable again. I can say numeric. And I said, how many are they? 5 people. Then I run this. Look at it. What do you see? What do you see at the scores? We have just empty scores. What I've just done is I've created a variable called scores, but has empty values. Now it is my duty now to now say, I want to add to it. I will now say data dot entry, and then I put scores and run it. So in this place, I'm going to say, let's say this person about 5, this person got 2, this person got 4, this is a brilliant person, this person got 3, and this person got 1. When I'm done, I close it. Look at the global environment. What do you see? 2, 4, 5, 3, 1. That's another style to create variable. So if you have any question, please allow me to just quickly round up this concept of variable, and then I'll give room for like a question or two, then we'll proceed. So this is another way to create a variable. And again, I can create a variable by saying, let's say, let's use another one again. I can say, what else can I use that is numeric? I can say salary. I can just say salary. I know we have a lot of big people here. Like the coordinator, I know she's collecting one big amount of money in dollars. I'm just joking. So you're going to be taxing the coordinator. Coordinator, come and give us a no, just on a very lighter note. So look at what I have here. I have salary, and I say scan. So then what you just need to do with this particular one is you go to the console, and then you begin to impute the variable you have for salary. Let's say the first person is getting, oh no, you go to console control 2, you press 2000, you press enter. The next person is getting 1500, you press enter. The next person is getting 3000, you press enter. You know there are 5 people. The next person is getting 35. Last person is getting 500 naira. So you press enter twice. And then when you look at it, we have salary created as numeric 2015. So you can run it to see, you can print, you can say salary, or you use the print function. You see salary, and you see salary 2,015, 3,000, 500. You can also see the one we have created scores as 2, 4, 5, 3, 1 on the scale of 5. Yeah, any question as regard variable creation before we proceed?
So I was just asking, thank you very much for this support that you're providing, really very useful. So I was just asking if we're going to get the video right after this session. I mean, right after this engagement at the end. Thank you.
Okay, the coordinator will provide an
Okay,
answer to that.
Okay. We're going to have access to the video on our YouTube channel. So we're going to share that, but it might not be today. So but we're going to have it maybe latest by Monday morning. We'll share it in the WhatsApp group and as well as on our social media handles. Thank you.
Okay, having said that about variable creation, let's learn one important thing again before we move about data.
Sorry, I have a question.
Please go ahead.
Yeah. Okay, so these are manually entered data points.
Yes.
What if you
yes.
have to enter a lot of data, like a lot of variable? Is this the way you, or we're still going to get there?
Yes, we'll get to that particular point. If you are entering a huge data, most importantly, you know, some of those data would have been imputed on Excel or SAS or any kind of thing, and then you can easily bring them into R. So when we get there, we'll learn about that. That's about data input and data output. Is that okay?
Hello, sir.
Is that
Sure.
okay? Thank you. So now we are learning data operators. Let's be brief. So these are very important. The first operators we are going to learn, we have learned that is assignment operator. Assignment operator, we have learned that. The next is the arithmetic operator. And I think we have learned that when we started, the arithmetic operators are just the plus, the minus, the times. So you could use 2 times 5 and you run it. You see 10. You could say 2 minus 5. You know the result is going to give us something negative. You could say 2 divided by 4. You have it this way, 0.5. You could say 2 percent. Let's start by saying 5%, 2. You run it and you could see it. What is actually going on here is that this is giving us the remainder. And you can also use this modular division. You see, percent 2, and here you're expecting to have 2. So this is going to give us the whole number. This is what we're saying. 2 in 5 is going to give us 2, remainder 1. So this particular division results in only giving us the remainder, and the other one, the flow, give us the what? It gives us the whole number. So there are 2, the modular division and the flow division. So these are few examples we have under arithmetic. We'll still treat an example with that. So let's learn relational operators. Let's learn relational, and then I'll tie it up with logical. So the logical, we're expecting to have true or what? True or false? False. So let's tie this relational with the logical. So if I have 3, if I say 3 is less than 5, you know, automatically I'm expecting to have something logical, either true or false. So if I say 3 is less than 5, I'm expecting to have true. So if I say 5 is less than 3, I'm expecting to have false. So these are just relational, trying to like relate this with this. So imagine I say 2 is equal to, now the concept of equal to, if I say 2 is equal to 2, what I mean is left hand side is equal to right hand side. This is wrong, because this equal to is exclusively used for assigning variable. So if you are going to use that same equal to, we use mathematically, saying left hand side is equal to the right hand side. So you're going to use double equal to. So if I say 2 is equal to 2, that means left hand side is equal to the right hand side. This is true. But if I say 2 is equal to 3, This is false because what we have on the left-hand side is not equal to what we have on the right-hand side. If I say 3 is equal to 3, so if you are to use the equal to in mathematics, the equal to we used to say 2 is equal to 4. I mean, 2 is equal to 2. Left-hand side is equal to right-hand side. On R, it's going to be 2 equal to, you're going to double it because the single equal to is exclusively used for assigning variables in R. So having done this, I can say 2 is not equal to 3. This is another way to say 2 not equal to 3. You see, this is true. So if I say 3 is not equal to 3, this is false because 3 is equal to 3. So that is that about relational operators and logical operators. We have what we call special operators. Special operators. So what do we mean by specials? We have learned one of them. So if I, for instance, I'm creating a variable, do I need to just create a variable? I can say 1 to 10. Look at it. This is an example of special operators. This full colon that we have here, this full colon just prints range of values from 1 to 10. So another full special operators that we have is percent in percent. I usually talk about, there are plenty, but because of time, we just talk about percent in percent. So where do we use this percent in percent? Let's take, for instance, what we have as 1 to 10. I just want to call it, let's just call it vec. And use the less than assignment operator and say C1. Let's just print it out as 1 to 10. And I run this. So let's say vec1, and let's say vec1 is just storing 1 to 3. 1, 2, 3. And then I run this. So when I mean percent in percent, this is what I'm saying. I can say vec1 percent of vec. Do you see it? The question is, can we find vec1 in vec? So I put 1, I imputed it into vec. That's the variable storing values from 1 to 10. So 1 is present there. It tells me it is true. Can I find 2 in this variable vec? It said true. Can I find 3? It tells me true. That's why we have true, 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 true. Imagine I change this now to 11. And then I rerun this particular thing. So now when I tested 11 to be sure maybe 11 is also present in variable vec, it tells me it is false because 11 is not present. Values that we have in variable vec is just value ranging from 1 to 10. So automatically this is going to give us false. We would see this probably, it is beyond the scope of this class, probably some machine learning or some kind of regression assignments. We would begin to do some of this kind of percent in percent. So that's just that about data operators. And then let's just go to data types. The data types we're just going to talk about because of time is just vector, list, matrix, and array. I'm going to take it fast.
Okay, so sorry, can I just a minute? Okay, thank you so much. You're doing a great job here. For those who are kind of much more professionals that are joining us today, where this series is about taking everybody along. We want both the newbies and the professionals to go hand in hand. We want to take up our newbies. So that's why we're kind of starting from like ground zero to carry everybody along. We want them to understand what R is and appreciate it. And that is one of the challenges we're trying to manage here in Abuja. So I would employ that you kindly bear with us. Let's encourage the new ones and let's all grow together. We're going to go into core data analysis, even if we have to extend the time. And I think we've been using some of the time for questions and answers now. So I think we still have some time that we can kind of use in our Q&A session. So kindly bear with us. Let's take along our new ones so that they will also champion R wherever they are in their workplace, school, wherever, even making decisions for the future. So thank you so much.
All right, thank you very much, coordinator. So let's proceed. We have learned about the data operators, the data types. We have learned about vector. We're going to learn about briefly matrix. We stop there because of our time. So when we, let's say the vec, we created the vec1. When I print vec1, look at what happens. It is 1, 2, and 11. It is possible for me to add a value to this particular thing to make it, to make the data we have in that particular variable 4. So what I would just do is to say the concept of reassigning, or yeah, the concept of reassigning, and then I say C, I combine it, and I said vec1. What am I adding to it? I'm adding, let's say, 12 to it, 12, 13, and 5. Then I run it. Look at what happened on the global environment. We now have 1 to 11, 12, 13, and 5. So I've successfully added numeric values to our vec1. So, and what I did was I wasn't creating a new variable to store it. I overwrite the new one on the old one. Now look at what is going to happen. So one of the things about vector is that it can only retain objects of the same, just one class. Now imagine I just come and I said I want to add something to this vec1, and I said C, open bracket, I'm writing something that is categorical. I say vec1, and then I put A. Look at what we have. It changes the class from numeric, automatically it turns it to character. So what the limitation we're trying to see here about vector is that it can only store just one class. You can't have it store numeric and at the same time stores character. Instead, it turns everything to character, as we see in this case. So that's one disadvantage about vector. So that leads us to what we call list. So with list, you can store more than, you can store object of different types. You can say, okay, list, and then you have vec1. I can say vec1, and then I can also go again and say bio, for instance. Then I run it. So it keeps them in their respective classes. That's one of the things list does. And again, before I move away from this concept of vector and list and talk about matrix, there is a way in which we can coerce. We can change from a class to another class. For instance, we have, by mistake, I've added A to vec1. Look at what is going on. I've added A to vec1. Look at, and it has completely affected the class of the variable. Now, what I'm going to do is first, I'm going to remove that last one. I'm going to remove that A. And A here is in position 7. So what I'm going to do is to say vec1 is assigned, and I say vec1 index remove -7. And then I run this. So if I run my vec1 again, look at it, the A is out now, but one of the problems we still have is that this particular thing is still seen as character. The class is still seen as character. How do I change the class from character to numeric? Then I say vec1, I'm rewriting again. Then I use this particular function as.numeric coming from the base package as.numeric. And then what am I changing to numeric? I'm changing this old vec1. I'm changing that old vec1 to numeric, and I'm storing it in a new variable called that's in vec1. This is overwriting, and then I run it. If you look at it, it is back to numeric. When I check again, when I run this, you will see it is no longer coded as character. It is now seen as numeric. That is how you can coerce, can change from a class to another class. All right. So having done that, let's just quickly move to matrix. From the examples we have been treating so far, it's more like a lecturer that has students, array names, he has their location, and he has their scores in a particular test he gave them. So how do we, there are some two functions that helps us in combining vectors into a matrix form. Let's talk about that. The arrow bind, there are plenty, but let's just talk about the arrow bind and the C bind. So arrow bind in this case means binding them together by row, binding variables together again by column. That's what we're doing. So imagine I want to come up with a table as a lecturer. So I can just easily say arrow bind, row bind from the base package and say, I want to see their names first. I'll say arrow. We already have a variable created called arrow names. I'll say comma. And then what else again? We'll move again to the location. That's arrow underscore log. and then we talk about the scores. And then I run this. Now, this is what I mean by binding them together by a row. So it binds them together in a row and brings it out in a tabular format. You look at it, arrow names. This tells us that this is Joke. She is from Canada and her score is 2. This is Kunle, she's from Nigeria, he scored 4. This is Dayo, Nigeria 5. This is Shola, Ukraine 3. This is Dupe, Germany 1. That's that about arrow binding them together by a row. And when you can also do that, C bind, this is just the difference. This one binds them together by column. So this is Joke. For you to know what Joke got, you have to just check. She's from the location is from Canada. The scores is 2. Kunle, Nigeria 4. That is the difference between binding together by a row and column. Imagine you store them in a variable and you call the variable AB in this way, and you run it. We have AB now stored differently, not as a value, but as data. And now, most times I always love to create a clear distinction. I always love to tell people that there is a difference between values and data. Values are objects that you create using vector functions most times, and data are just combinations of values. What we have as data are combinations of the values you have created initially with the vector function, and that is what is playing out there. So the class of this particular thing now is still going to be seen as a matrix. Class of ABA, you see it is seen as matrix. And why do we still have it as matrix? Because these functions are just matrix enabled functions. So we move away from that. How do we create like matrix from scratch? Imagine you are a mathematics student. So let's say we have a variable called vec, or let's say BC, for instance, and I have C 1, 2, 3, 4, 5, and 6, and I run it this way. So how do I create a matrix? Very simple. I say matrix. That's the function we use in creating matrix. You could see you put the data, then you put the number of rows you want and the number of columns you want. And these are some additional arguments you can use: the dimension names, the by rows, and the by columns. So look at the data we're using is back in forming this matrix. And then I come here and then I say n rows. Let's say 2, and then I say n col. Let's say 3. 2 by 2. Can you see? This is a way to create a matrix. So this matrix, the dimension of this matrix is matrix of row 2 and matrix of column 2. For those who are from a mathematics or science background, you will know that this kind of matrix is the kind of matrix we call square matrix, that has the same row and the same column. So this is how typical way you can create matrix using R. So we move away from here, and then we move to the point of having data frame. Yeah, data frame. This is the acceptable format of creating table on R. Now, the way we have it here, where is that ABA that we have? This ABA, the class of this ABA class, like we have seen, ABA is as matrix or an array. And most times, it is always good you have your table on R in the data frame format. When I mean data frame, the same way you always have it on Excel, you know, when you bring it down to R, the best way to create a table on R is using a data frame. So you can change the class of this one from that matrix it is to a data frame. We'll do that later. So let's create a data frame. Very simple. You just say we're having results. Let's say I'm a lecturer. That I am results. Then I say data.frame. Look at it, data.frame. And then you just put in the variables that you have created initially. The first one is arrow underscore names. Arrow underscore names. Arrow underscore log location. Arrow underscore log. And then scores. So I run this. And now we have results here as 5 observations of 3 variables. You could see that there is a difference between the result and ABA. This one is having an icon in front of it. This is ABA. ABA is just still in the form of a matrix. And that's why you see it as CHR, and then you see it, this particular indexing. That is how you can index variables, observations that are present in that above variable. But in this case, this is the best way a table is meant to be created on our result. We have 5 observations of 3 variables. So you can check, you can click on it and you see it here. So this is Joke, CND2, this is Kunle, NGL4, etc. So that is data frame. And again, you can create a data frame directly by saying, let's say this is DAD, for instance. I have data.frame, and then I can start by saying vec2, say vec2 C, 1, 2, 3, 4, 5, and then comma. I can say NAM in this way. I say NAM is C, open bracket. Okay, because of time, let me reduce this particular thing to 3. So the example can be clear. I can have it as A, comma. I can have it as B. I can have it as C. So then I run this. You can see we have that again of as 3 observations of 2 variables. Do you understand? Let me attend to question at this junction. Any question? Hello?
Hey, do we have any question?
This junction, let's just quickly attend to questions.
Yeah, I think I would suggest we use the time well. That if you have questions, just send them into the chat box and we'll be able to select the time to attend to them.
Okay.
So that we can cover what we really want to achieve. There's data analysis using R. We're going to analyze it and look at the core stuff. And I think our speaker is also taking note of the time. So I think that's what it's better we'll use the time well. Thank you.
Okay, thank you very much for that. So what I did was I just actually went through the basics so we could go into the basic thing we have for today. Now I've actually made some kind of good impression with the basics, and I believe some of us that are here that are new to our would have gained something from the basic lecture we just had. So let's learn. We have learned about data operators, data input. How do we input data? Like someone asked the question the other time, a data we can bring in and use for analysis, be it descriptive, be it inferential. So let's learn that. So I'm going to tag it data input. Data input and output. Data input and output. And then the first thing we learn is how do we set a work environment? What directory? So how do we set a working directory? So what do I mean by working directory? Working directory means the exact folder. How do you set Arrow to connect to an exact folder on your system? So Arrow can now have access to every information, every files that you have in that particular folder and read those things into Arrow for you to use for analysis. How do you do that? So I'm going to give a simple example. Please, can you see my screen? Let me take it back to documents and let me bring a data set that we can use for practice. Okay, I have a data set called, this is for trading class. Okay, let me just bring in this particular data, Euro USD 60. Let's learn how we can bring this Excel file into Arrow. So the first thing we have to learn is how do we set our working directory? How do we connect Arrow to a certain folder? Now let's go. I'm going to teach us how we do that with the menu option. You go to section and then you say set working directory, and then you go to choose working directory, or you press the shortcut Ctrl+Shift+H. But how do I know the exact directory I'm working with presently? I'll use this function from the base package get WD, and then I run this. So this tells me that I am working, my Arrow is connected to the document folder. So if I'm bringing in anything, any kind of data into R, the data must be dropped in this particular folder, this folder document. So imagine I have a data set that is present inside this climatic research. I won't be able to read it until I set R to read information that are present inside this particular folder. And again, if it is inside 2000 to 2019, I've set it to read from it. If it is inside 2014, then I set again to read from it. Let's learn how to do that. So imagine I have, I want to change the working directory now to where I used to store some data set. I would say section, set working directory, and then I choose working directory. Then let me take us to where I store Olakunle, R test, and then I have data sets. Then I say open. So automatically when I change the working directory, everything here at the level of file pane also changes. So this in a way reveals all the files we have in that particular folder data sets. So these files that we have in the data set are data that we can use for practice. So that is how you can set your work directory using the menu option by going to section. So imagine I have, and then it makes importing of data very easy. Imagine I have, let's take an example of this particular acquisition. No, let's go and use student performance. I use that often to make things very easy. Student performance. Okay, this is student performance. So imagine you want to read this particular thing inside. Now it is very easy. You can just click on this particular place. You can click. And then you click, you see the option there. You can import your data set. Can you see my screen? I love to hear from people. Can you see my screen, please?
Yes, sir. Yes, sir.
Yes,
Because we are going into the core job, yes. So you just import data set and then it becomes very easy. You can just click on it and then you make some settings. You can change the delimiters, what we have in separating them based on your understanding of the data, and then you just import. You can see the code R has used in helping you to import it. Then you click on import and it brings it out for you. So that is how you can set your code using the menu option. You can also set your code again using just writing it yourself. So you can say set WD, set working directory, then you say directory equals, you have an existing thing here. I can set it back again to document, Control C, and then I paste it here. I can set it back to document. So if I check my working directory again, it is back to document and no longer set to data set as we have it in this case here. So imagine I want to set it manually to that data set I have, and this is very important. So I'll say set WD, open bracket, directory equals, I copy that same thing again. Then I use this particular delimiter. I put what I have here, /. Then after document, this is the way you direct your folder. Imagine you have, like now, the data set is not in document. It's in a folder inside Olakunle. I set it to Olakunle. Then, okay, the next thing, you come here, you write Olakunle the way it is being spread. You put the / again. I notice it is in R test. Okay, and then after R test, I have it as data sets. So how do I set it in such a way that it will follow this particular movement? Olakunle, R test, and data sets. So you spell it the way it is spelled, Olakunle, R in capital letter, T in capital letter, because R is case sensitive, and you put test, then you put what again? You put data sets. That's all. And then you run it. When you check your working directory again, you would see that it is already set to data set. And then you can easily read in data that we have in that particular place. So the data we are bringing in today is the data called student performance because of our time, and it is a CSV file, comma separated value of variables. So let's go. How do we read in a CSV file on R? This is what we'll do. We can give it a variable name and say that's what we're using, and you assign it, and you use this function for reading a variable into our use read.csv. And then what are we bringing in? The data name is called student performance.csv. So what you just need to do is to say stu quote it stu. While pressing stu, just press tab. It will just suggest for you data set that goes with that particular pattern. And then what are we interested in? We're interested in student performance.csv. Why I usually suggest we use this when working on arrows to do is because most times you look at now, this particular P is in capital letter. Somebody might be trying to import this particular data now into R and put small letter here. It might work, but in most cases, you would always encounter some errors. So it is better we use this, use tab, and then you just press enter when you are at the particular place. Tab, and then I scroll down, then you run it. So when you look at your global environment, what do you now have now? You have that as how many observations? 1,000 observations of how many variables? 8 variables. Is that clear?
Yes, yes.
Okay.
Yes.
Okay, good. Let me clear our global environment so we can just, to not be too busy, ls rm list equals. So let's go back again and run this. Okay, good. So you can check and you see the kind of information we have inside. So this is it. We have the first variable we have is what? Gender, right? The gender is just categorical in nature, and it has 2 levels, female and male. We have race.ethnicity. We have parental level of education. We have lunch. We have test preparation course. We have math score. We have reading score, and we have writing score. So that's that about that. So let's take, for instance, you are to do a descriptive analysis. Let's start from that. When you see data analysis in R, it's a wide thing because a whole lot of analysis can be done. But I'm just going to restrict it to something basic that every one of us can understand. So let's talk about descriptive analysis. So with this descriptive analysis, we talk about measures, central. I don't even write much. Let's say centrality. And 2, I'll talk about spread. Okay, good. So the very first thing you need to do is we have to carry out what we call an IDA, initial data analysis or exploratory data analysis, EDA. So why are we doing this is on R, it is important. You have to check the class of each of those variables to be sure that they are in their right classes. Some are meant to be factored, but they are still taking the class of character. You have to ensure that all these things are properly done. I gave an instance the other time when I was talking about categorical variable, those that are nominal and ordinal. Imagine there are some kind of variables that we have that are meant to be classified as ordinal, and then you still leave it as character. So it could be very, it could be dangerous. It could be dangerous, and it could lead to a wrong kind of analysis in the end. So that is why it is important we have to do this kind of EDA. And one of the very basic things we do with the EDA is you can get the names. Imagine you are interested in seeing the headings. So you see names, and the argument that goes inside is the name of the variable. So how many column names do we have now? We have a name for gender, race.ethnicity, parental level of education, lunch, etc. to writing score. So you can also check the structure. This is an important thing. You can check the structure, and then you put a variable inside, and you see my screen. Let me make sure I make this big. Okay, good. Now we have gender. Gender is of what class? As seen here. It's of what class? Character, right? Let's respond. Gender is of what class? Character, right?
Yes.
Yes, sir.
But ordinarily, as a student of statistics, is gender still meant to be classed as character here?
No,
No.
since we
So
have it as character already.
we have to factorize it. We have to factorize it so that we can easily see that there is a difference between female and male. Because there are some analysis we want to do. We want to see the impact of male on certain variables. We want to see the impact of female on certain variables. So if we don't change the class from character and factorize it here using the factor function on R, then even if we go ahead, if you have the code, if you go ahead running the code, you would find yourself in a big error. Do you understand that?
Yes,
Yeah.
So that is the essence. That is the reason why we're checking the structure to ensure that the classes are in the right place they are meant to be. So look at gender, race dot ethnicity. This is also, it also has some kind of finite levels. I'm also going to change this to factor. We have parental level of education. We're going to change it to factor, and I will tell us why we're doing this. We have lunch, the standard. We're going to change that again. Let's scroll down and see some other ones we have. We have the math score, still seen as integer. I might change this to numeric. Reading score, changing to numeric again, and this one. How do we do that? Let's learn how to write that code. I hope I'm not too fast.
Yes,
Are you sure?
Yeah, it's okay.
Okay, good. So having done this, I want to change this class and I don't want to affect the name it is carrying. So I would say I have it as that. I'm changing gender. So I use the $sign. You can see anytime you want to make reference to a certain variable in a data set, you use the $sign. So you said gender, and I'm saying this particular thing that I have here, I'm saying as factor. Let me break down this thing so you can see my screen very well. Okay, good. So gender, and then I'm turning it to factor. What am I turning to factor? That, changing the gender. If I run this, you will see the effect. Briefly, before we go, let's check the structure again and see what we have now. What do you have as gender? It is now factor with how many levels?
2 levels.
2 levels. What are those levels? Female and what? And male. Now imagine I've not done this, and probably you are working in a particular organization and somebody just came and said, please, how many levels do we have for gender? And you have this 1,000 observations. Will you not be counting? Will you not be scrolling and say, oh, maybe we have somebody who is hermaphrodite or transgender there? How would you know? And you have 1 million data sets. So that's why it's good to factorize them. And then when you factorize them, you can now use this level function. See levels? I say that $sign gender. It tells you immediately, even if it is 1 billion data set, it tells you the unique values, the unique levels that we have. The unique levels that we have that were repeated 1,000 times are just female and what? And male. Simple. Do you understand the importance of factorizing it now? Okay. I hope we all are following. So the next one I'm changing is I'm changing this one again. I'm changing race.ethnicity so I can actually know the unique values we have there. I'm going to say as dot factor, and then I have that $sign race.ethnicity. I run this. Let me change one again. Parental level of education, and then I say as dot factor that $sign parental level of education. I run that $sign launch, and I say as dot factor. I say $sign launch. Do you understand? And then I'm changing this one again. Math score. I'm changing it to numeric. So I'll say as dot numeric that $sign math score that $sign We are just doing all these things to prepare ourselves for our analysis. As numeric, dollar sign, reading score, that dollar sign, writing score, as dot numeric, that dollar sign, writing score, dollar sign, writing score. So that's good. If I check the structure again now, the structure for that, you see all these ones that were formerly known as integer, it is now seen as what? Numeric, numeric, numeric. Let me also do one more thing. That dollar sign, this test preparation cost as dot factor, and then that dollar sign test preparation cost. Now, if I want to check the unique level, for instance, somebody is asking you how many rays are represented here? How many rays are represented in this particular data? You don't need to stress yourself. Since you checked and you are sure that the particular race dot ethnicity is now factored, you can just say levels, and then you see that, and then you make reference to it, and you see race dot ethnicity. You run this. How many races do we have represented? Group A, Group B, Group C, Group D, and Group what? And Group P. So these are just the unique values that were reproduced 1,000 times. Do you understand? Do you understand?
Yes.
Yes.
Okay, let's take for instance that our interest now, we want to get out informations that belongs to Group A alone. Are we together? Let's say our analysis is going to be done on Group A. How do we bring it out from the entire data set that we have? So I'll say SAMP or SAMP in this way. And then let's learn how we can index. Then I'll say that. Are we together?
Yes,
okay,
sir.
Then I say square bracket. There are many ways we can do this, but time will not permit me. But please just follow up with what we are doing now. And if I'm too fast, tell me. I can bring it down. Like the coordinator have said, we can always have like some time again to do some other things. So we say that. And then what are we interested in? I said that dollar sign. I'm interested in race dot ethnicity. That is equal to what? Thank you, Group A. Group A. And then this is the condition for the row. And then I put the condition for the column and I run it. And when I look at my sample, we just have 89 observations that match up with that condition. If you scroll down, everything I have here are just informations about the Group A alone. So imagine my analysis is to be done on Group A alone. I am not doing it on the entire 1,000 observations. So I'll just write my code this way. Some of us might be confused that, okay, how did you do this? This is it. I'm going to use an existing data set that we have. We have an empty class data set. I can check the head. You can get the first 6 observations of that particular data set. This is it. You can scroll up. This is it. What do we have? We have information about the miles per gallon, cylinder, displacement, horse, power, DRAT, WT, right? Can you see it?
Yes, sir.
So now let's take, for instance, that you are working in this particular company. This is the entire data set, like I've shown. Let's have it stored. Data. Let's have it stored. Empty class. Let's say this is it, empty class. Can you all see my screen?
Yes.
Okay, let's take, for instance, your boss came to meet you and asked a question from you. How do you answer this question? He said, please, in our store, where we have series of cars, how many vehicles do we have that has 6 cylinders?
Sorry, hello.
Yes, please ask a question.
Okay, I'm actually the coordinator here. So please,
okay.
Is it possible that you can share the data file, that's the CSV file, that we can share on this webinar? Somebody is asking if they can get it and follow along with you.
Okay, it's possible.
Yeah, you can share it through the chat
option.
yeah.
Let me do that now.
Yeah, so
Computer. So just give me some minutes, 1 minute, I'm done.
okay.
Okay, please, you can now check for it.
Okay. Okay, so for those who are requesting for that, the scripts would not be shared now. The codes, you have to kind of see if you can, or can we share the script too? I don't know. I don't know.
No, let them follow at the end of the class with the
Yeah,
YouTube.
we
They will
share
have a
the
link.
script.
Yes, they will have a
Exactly.
link to the script.
Okay, good. So thank you so much. You can continue.
Okay, thank you very much. Okay, I hope we have all seen it, the data set.
Yes.
Okay, good. So the question is because while we are trying to like make the knowledge of Arrow popular, we're also trying to be conscious so that we don't just teach it in a rush. The goal is to ensure that everybody are familiar with Arrow, and that's why we're doing this kind of thing. So anywhere you are, you can work with it. I'm saying, for instance, you're working with an automobile company and your boss just came and you have this particular data set in your store and it's asking you how many vehicles do you have in your store that has 6 cylinders. How do you do that? Now, if you look at Mazda RS4, how many cylinders does it have? 6, right? Look at Mazda RS4 wagon, it has 6 cylinders too. What about that Sun 710? How many cylinders?
4.
So that means this one will be excluded when you are writing out your code finally. Do you understand? So how do we do that? How do we do that from that particular data set? From this particular knowledge we use in creating out information that belong to race.ethnicity. This is what you do. You would say empty cast, that's the data set, and then you index. I told you square bracket is for indexing. Do you understand?
Yes.
And then what will you do? You would say you're interested in empty cast $, cylinder, that is equal to what?
6.
Equals
How
6.
many equal to will you use? Is it 1?
2.
No.
Double equal.
Double. So you say 6. This condition is the condition for the what? For the row. Then when you have imputed the condition for the row, you say comma. You impute the condition again for the column. If you leave it empty, that means you want it for all the columns. Are you with me?
Yeah.
So if I run this now, I will have
Yeah.
it. This is it. These are the results.
Oh.
Can you see it?
Yes.
All of them are
Yes.
just 6. Now, your boss is asking you that how many are they? How many are they? Are you with me? So I will say number of rows. I will say n rows, and then I put it here, and then I run it. How many vehicles do we have that has 6 cylinders now in your store?
7.
How many?
7.
7. How do I get that? I just included this function, number of rows, and then I put it. Do you understand?
Yes.
So that's that about that. Imagine your boss is now asking you that how many vehicles do we have that has 6 cylinders and at the same time has 6 cylinders and at the same time has what's this thing? Sorry, how many has 6 cylinders and at the same time has gears that is equal to 4? Look at it. Mazda RS4 has what? How many cylinders? 6 cylinders. How many gears?
4 gears.
How many of them match up with that condition? This one match up with that condition. Mazda RS4. Mazda RS4 wagon match up with that condition. But does Honest 4 drive match up with the condition? No, because it has 6 cylinders but doesn't have 4 gears. 4 gear system. Do you understand? So how do I get that? I will come back to this particular place where I have my row condition, and then I will use these particular operators. I didn't talk about it. I skipped it. This AND operator. Do you see it?
Yes.
I'll say AND and I'll say empty cast, $. What are we looking for? Gear that is equal to what?
4.
If I run this, how many are they? They are just 4. 4 of them. So you can tell your boss that, okay, sir, we have 4 of them that match up with that condition. What are those 4 vehicles? You can run this one alone. How many of them? These are just the 4 vehicles. Mazda RS4 wagon, Mercedes 280, Mercedes 280C. Do you see it?
Yeah.
So imagine you want to impute a row condition. You want to impute a row condition. That is, you don't want to print all the rows. So you won't leave this place empty. You would now say, if you are interested in column row 1 alone, you say 1. Look at what will happen. If I run this,
Hello.
let me copy this out. Ctrl Z, Ctrl V. If I run this, you see it only prints it out for what? For what column?
Column 1.
Thank you. Print out the information for column 1. Imagine I'm interested for column 1 and 2. If I do 1, 2, it will give me error because it won't give me the exact thing I'm looking for. Are you with me?
Yes.
If I say 1 to 2, look at what will happen. It is then it can give me MPG CYL, which is in line with what we wanted. If I say 1 to 5, look at it. It prints out for the first 5 columns. Vehicles that match up with this condition, and we're interested in the first 5 columns. Do you understand that?
Yes.
Okay, good. So what we have done here, you can also do that using the subset function. You say subset, you put empty cast. Are you with me?
Yes.
Only one person is giving a response. Okay.
Yes.
Okay.
Yes, I'm with you.
Yes.
So we say empty cast. What do we do here? Then we say cylinder. In this place now, you don't need to be calling cylinder now with respect to empty cast again. The moment you are using subset function, the first argument you put is the data you are using, and then you just go ahead and say cylinder, CYL, that is equal to what? Equal to 6. First, if you run this, it prints out this particular one for you. So if I say and gear, you don't need to be pressing empty cast, just say gear, that is equal to 4. If I run this, it prints out this for me. Do you understand?
Yes.
So imagine I can say select. If I say select, I'm interested in 1 to 5, like we have here. Select 1 to 5. Look at it. It prints out this for me. That is with the subset function. Now, this particular line of code I have in 166 is the same thing with the line of code I have in what? 164. Do you understand?
Yes.
So there are different ways in which you can do this. Are we together?
Yes, sir.
Okay, I can also do this again now, but I'm not going to write the code on the base. I'm going to write the code with the help of a library called the dplyr. You might not have that library. You might not have that particular package. If you don't have that package and you want to install it and you want to follow what we are doing, you just go to this particular pane where we have package. Can you see install? You click install and you press dplyr, dplyr, and then you can install it. You run it and it begins. You must be connected to the internet to do this. I'm connected now. Then you install and then it starts downloading from the comprehensive archive network. And then when it is done, you can now load it for use by using the library function as I'm doing here now. And then you can have access to all the functions that we have inside the dplyr package. I think we have up to 200 functions in this particular package. I don't know, maybe it has been updated now, but they are up to that number. So imagine I want to do this now. I can say this particular function is from the dplyr package. I will say filter. Then I will put the data I'm filtering. I'll say empty cast. Then what am I filtering? I'll say CYL that is equal to 6. I run this. That's it there. Any question?
Yes, I just posted a question.
Okay. Sometimes not all packages are available for some computer types and R types. What do we do in that case? So sometimes some packages are not available. Maybe they're not available at the comprehensive archive network. You can get them on GitHub. It is possible you get them on GitHub.
Okay.
Yes. Or there is another one again where you can get it is BIOS. I can't remember. But majorly, if you can't find them on the comprehensive archive network, there are ways you can get them on GitHub. Or if you are good with manual installation, you can do that manually. Download the zip file or the GTZ file, and then you bring it into your R, and there is a way you can do that manually. You go install, and then you change it, you see, and then you go to this particular one. If you are using the tag.gz, and then you just click and you select the exact place where you can find that thing which you have downloaded, and then you can do that manually. I hope you understand this concept. Now, what we are dealing with now is just the concept of indexing. How do you index? How do you pick out a fragment from a whole? That's what we're learning. Do you understand?
Yes, please. Thank you.
Okay, thank you very much. So where we were coming from, we have this particular that. Are you with me? And it has 1,000 observations of 8 variables. But I said the class work your professor gave you is to work on race that belongs to group A. Maybe those races are African people and your research is on Africa. So what do? The first thing about this analysis is we are learning descriptive analysis, and then you can just say summary. That's one way to do that. You can see summary. And then what are we looking at? You see summary sum. If you run it. So this summary function does bring out a very good result on those that are variables that are numeric. Look at it. We have gender. How many females do we have? How many females? 36. We have 53 males, and all of them are all what? Coming from race.ethnicity A. And then we have, these are some of it, associate degree, we have 14 of them, bachelor's degree, like that. You have reasonable information about that. Those that have free and reduced lunch, 36, standard lunch, 53, test preparation course, 31, for those that have completed it. For those that have not completed, we have 58. And we have the math score. Now, this is the descriptive statistics. We have the minimum, 28. We have the first quartile, 51, the median, 61, the mean, 61. And then we have the third quartile to be this, 71, and the maximum. All this you can also get by doing them in this way. Minimum for SAM. Let's say you want to get the minimum for writing score. Let's just be working with writing score. This is it. The minimum is 19. You want to get the maximum, you use the max function. You say SAM. You are working with writing score, and then you run it, 97. If you want to get the range, you can say range, and then you say SAM, $, $, writing score, and then you run it. You could see it from 19 to 97, which confirms our minimum and maximum. So you can get the mean, and then you say SAM, $, writing score. You can get like that. These are some of the things you can do using just your code on the base R. Any question as regard what we are doing now with the descriptive statistics? Any question? Just a question, one question. Let me check the chat. Why did you feel those numeric variables from integer to double? Why do you feel it is necessary? Why do you feel it necessary to change those numeric variables from integer? Okay, good. Someone just asked the question that why do I think it is necessary to change them from integer and take it into numeric? So you can leave it as integer. It is not the error, you won't have any error. You won't have any error, as the error you would have if you have left that one as the class of character instead of a factor. So you can still leave it, but I choose to take it away from integer and take it to numeric, because I know numeric just there is a difference between numeric and integer. Integer just have some range. From 1, you can say from 1 to 5, 5 to this, 10 to this, and that's not the case with the scores that we have. That's why I changed them from integer and I turned them to numeric. So still on that descriptive statistics, because of our time, descriptive analysis, there is a package you can also download. I'm sure I have that library that would give you this everything once and for all. So what we are just still dealing with is the concept of centrality. All these things we're still talking about. It's talking about the centrality of the data, the minimum, all this, the minimum, the maximum, the range, all those things talked about, the mean, the median, all those things talks about the centrality. So to do that, you can just use this library, psych. Do I have it? Good. The fact that I don't have it means we need to learn how to download. Okay, I have it. Library, PS, YCH, and then I run this. So it's ready for use. There is a function in this library that makes descriptive analysis very easy. You just say describe. And what are you describing? I say samp $sign writing score. And then I run it. Can you see my screen? Hello, can you see my screen?
Sure, you can see your
Okay,
screen.
so you can see it
Yes,
prints out a whole lot of information about
Yeah.
that particular writing score. We have VAS, we have number that we used, that's the N. We have the mean, we have the standard deviation, we have the median, we have the trim, we have the mean absolute deviation, we have the minimum, we have the maximum, we have the range. So beautiful. We have the skewness and we have the kurtosis. We have the standard error. So this is one of those functions in the library, in the package like that makes descriptive analysis very easy. Any question? No question. Another package again I'm going to introduce us to that we can learn, or when we have the video, is the library, the package moments. If you run this one can help you again. You can just get the skewness to confirm. I love doing things and making my confirmation. I can see some $sign, writing score, and check the skewness. Look at what we have as the skewness is 0.04. Does it correlate with what?
Yeah.
It does, right?
Yes, it does.
Okay, so I can say kurtosis. Time will not permit me. This is not a statistics class. Would have been talking about the essence of some of these things, but let's just go into after this descriptive statistics, we'll go into inferential statistics. We'll do some few analysis and we're out of it. So samp again, $sign, writing score, and then I run this. So it does correlate again with what we have as our kurtosis too. So let's move away from here. Talk about a bit of inferential statistics. Inferential analysis. Don't let me get us afraid. So before we go, because this is going to be the last part, before we go, any question?
No.
Okay, good. I have prepared this code. I will share. Yeah, this is the one we're going to share. So let's just go to, where's the place I prepared for inferential statistics? Okay, this is what I'm going to do now. I'm going to run through them. We have a lot of things about inferential statistics, a lot of them. We have the t-test, we have the chi-square test, analysis, but today I've just decided to just talk about modeling. Are we together?
Yes, sir.
Yes, I've decided to talk about modeling, putting everything into this concept, this aspect of modeling. And what do we do? For instance, you want to see from this particular data set that we have, names. Let's still be working with SAMP. We have gender, race, ethnicity, etc. Let's check the structure. The structure of SAMP, and then run it. Okay, all of them are well in the right classes now. Let's say now my interest, what I'm interested in is I want to predict. Okay, to do this, it is better we just use a simple example. Let's use a simple example. Let's call out an example. Let me use an example that I can use in making this thing very easy. Okay, I have a data set here, trees. Let's check the head of the trees. Are we together? Okay, the coordinator will attend to that one. Somebody asked the question on the chat room. Yes. So let's check the head for the trees. We have height and volume, right?
Hello, sorry. So sorry, can you give us, let him round up with what the stage where he is, then he will be able to attend to the question.
Okay, so
Okay.
like I said, we have a lot of analysis we can do, but I'm merging up everything under this concept of modeling. So look at it, we have this simple data set that we have, default data set called trees, and it has information about get, height, and volume. And now let's take, for instance, we want to model volume. We want to model volume. When I mean modeling, that is, we want to predict volume. We want to create a model that can easily predict volume without you, as long as you have information about the get and the height. Now, what do we do? Very simple. This is what we do. Then I'll talk about the concept of linear non-linearity. Then talk about this model. And finally, briefly. So to create this, to develop a model that is linear, that can predict volume, this is what I will do. I will call it mode. I'll store the result in mode and use what we call linear model. So I will explain why I'm using linear model. Okay, I think it's better I explain that first. Let's check the plot. Let's say plot. Let's check trees. Making reference to this $3 this, and then I have $3 height. Let's see the correlation that is going on between these two parties. When I zoomed it, can you see my screen?
Mm-hmm.
Yes.
Okay, what I have here is a scatter plot showing the relationship between get and what?
Trees and
height. So I can assess the strength of this pin by using correlation and say get trees $ what? Get, and then comma trees $ what? Height. Yes, I can access this. You could see the strength is not that strong, right? So I'm just trying to work with time. If I'm to do this, it will take a long time because I love to explain in such a way that people will understand. But please, let's follow. I have this now. I have plot again, $ get. I want to see how these ones affect what we're about to predict. Trace $ volume. And then I run this. Let's see. Can you see the zoom? Okay, I have one already zoomed out. Now, can you see this?
Yes.
Now you could see that from this scatter plot, I can see that get has a great impact on volume. Can you see it? Because there is this kind of high strength going on between them. Can you see it is linear?
Yeah, it's a linear.
It is linear. So now I close this. I can access the strength again by saying core and saying trace $ get, comma, $3 what?
Volume.
You could see that the strength is very strong, very high. Are you with me?
Yes.
So let's check again. Maybe height have any impact, greater impact on volume. I'll say plot. Now I don't want to be using this $3 again, so I will use this attach. And I will say attach trees. When I attach trees, all the variables that we have inside that tree data set with the attach function will be available on the global environment. So I can call them directly without saying trees. So I'll say, yes, I'll say plot. Instead of saying trees, I'll just say height. I'll spell it the way it is spelled, and then I say volume. Are you with me?
Yes.
So if I plot it, let's check. I have one that is zoomed already. Let me close it. And then zoom this. Do you see that the relationship is not strong? Can you see it?
Not strong at all.
Okay, so when I close this, I can access the strength by saying correlation and say what again? Height, comma what?
Volume.
Volume. Can you see it? 0.59 this. Now, what I'm trying to bring out here now is that imagine I want to build a model for volume, for predicting volume. Now, which of the variable do you think would be very relevant in the model? Which of the variable do you think will be very relevant in the model between height and get?
Height and height and volume.
Yes, height and volume.
No. I said I'm predicting volume. Volume now is the dependent variable from the independent variable we are using, from the predictor variable we are using in building volume, which is height and get. Which one do you think is much more relevant in this model now?
Gate.
That's the gate, because it has a greater impact in predicting volume. Do you understand?
Yes.
If I'm building my model like what I was doing before, I'll say I'm storing it in this particular object called mode, and I'm saying linear model. I open my bracket, and what am I doing? I say linear model. I said volume. Volume is replaced with what?
With get.
With get. Let's try get and height. Get plus what? Plus height. And then I say comma. Data. What data are we using?
Trees.
Thank you. Trees. And then I run this. So I already have my model built. Are you with me? You see it, list of 12. How do I get some of those things? You can say mode, and you can use $sign. It tells you the coefficient of the model, the residuals of the models, the effect, the rank, the fitted values. Now these are the predicted values. Are you with me? That the models are predicted for what? For volume. Are you with me? So if I run it, these are the values for volume that the model has predicted. Now, what I'm trying to say, or everything we do with inference is just we are trying to like get something about reality using statistical approach. So when I said I'm modeling, what I'm doing is that I have something that I already have. I have a data that I've observed. And now I use the observed data now to predict, to build a model that can be predicting that thing that I have observed for me. So imagine I will still show you a question from a university in Australia. I will show you, and you will see how this particular thing is very, very useful anywhere, any industry in the world. So now let me explain this concept of what we have done here. We have observed volume. What is the observed volume? This is it. $3 what?
Okay.
No, $3 what? Volume. This is the observed volume. Do you understand?
Yes.
Okay, this is the observed volume. And then we now have this as the fitted volume. Now let's check something. Let's check the summary for this particular model we have mode. Look at it. This is the summary. This is the formula. And then these are the residuals. The residuals are the error of the model error. And then you see the coefficients, the estimates. You have the standard error. We have the t-value and the p-value to tell you, okay, is this significant or not significant? You see the signs beneath here. And then let's look at something that is very, very beautiful. How do we have those residuals? I'm going to explain it to you. The residuals is just the observed minus the predicted. So the residuals is what? Observed minus what?
Minus predicted.
Now let's do something. I'm going to say res like this. Not resolution, but just let's have it as that. I say data.frame. I can explain this thing very well. So the first column will be for the observed. Are we together?
Yes.
What's the observed? Volume, Abi?
Yes.
Okay. What's the fitted value? What's the value that was predicted by the model? That's mode, $sign what?
Flat repeated value.
Repeated values. Now, you know, we have the residuals too, right? Mode, dollar sign what? Residuals, Abby? And then I just want to prove to you that the residuals, which is the error, is the difference between the observed and the what? The predicted. So what I will do is to say the last column will now be for what? Volume minus mode, dollar sign, what? Predicted values. If I run this now, what do I have as my res? 31 observation of what?
4 variables.
Let's check it. What do we have? This is the observed volume, Abi.
Yes.
This is what the model we built, the linear model we built predicted, Abi.
Yes.
This is the model residuals, right?
Yes.
Does it correlate to the difference between the observed and the predicted? Yes.
Yes, it does.
So when you hear residuals of any models, what it means is the difference between the observed value and the predicted value.
Yeah.
Do you understand?
Yes.
This thing is important a lot in statistics because when we have a plot for that and a lot can be deduced from that particular plot. But because of our time, we just won't go beyond this level. But I hope you understand this.
Yes.
Now look at it. Let's check how well the model predict our data. Now here we have an observed volume of 10.3. It gives us a low prediction. Can you see it? 4.83. We have 10.3. It has 4.55, right? We have 19. It does performs a bit well here, and here to 18.8. Do you understand? Do you understand that?
Yes, sir.
Okay, good. Now, what is the essence of all these things that we have been doing? What is the essence of we saying we are developing a model? The essence of it is to make predictions. What do I say? Yes, the essence of it is to make predictions. Let's go back to our model. Let's check the strength of the model. The strength of the model we see, if you look at this place, what did I tell you? We already knew from the correlation analysis we did with get and volume, height and volume, that get has a greater impact, right, on volume. That's why we have the significance very high, much more compared to that of height. What this is telling me is that I can remove height from this model. I can do away with height and just run my model by using get alone. You understand? I will still get something much more reasonable. So I can go back to my model and just say get. I just run it alone with get, and I run it mode. I come down again. I check the summary, and you can see it is much more better. That shows that with get alone, the model can tell us a whole lot of variations. It can explain a whole lot of the variation going on in that particular model. So we are fine with that one. So having done that, there is one more important thing again I want to tell us, which is, okay, let me come down and do that. You can just say plot and say plot of mode, and you run it. So then you can begin to see each of those plots. Let me make it big. Let me make it big. And then you see here, you just hit enter. You see the residuals versus fitted plot. For a good model, this red line is meant to follow this particular straight line that we have here. All these particular ones that you have are a ways of detecting some outliers. The 31, the observation in position 31, and this one that we have in position 19 and 20. So if I press enter again, it shows me the normal QQ plot. And this thing is still trying to like reveal the presence of those particular strange values, this 31, 19, and 20. On a normal ground, it's also meant to follow this particular straight line. That is when we have a model that does perform very well. So if I press enter again, I have that standardized residuals against the fitted values. You can see this is also meant to go along with this particular place where we have one. If I press enter again, I have the residuals versus leverage, and a whole lot of information can be derived from this particular place. Do you understand? Any question? I'm seeing the chat room.
At think there's no questions for now.
Okay, no question. Now, I hope you understand that. Okay, so that is that about linear model. From the script, you will see, let's just walk through the script. I have, aside linear model, we didn't talk about chi-square. We have learned something about descriptive. I've told you some of the functions that you can use in doing your descriptive analysis. I mean, first of all, having good insight is very important. You don't just jump into your analysis without having to do your EDA and also this concept of descriptive before you now move into your inferential analysis that you want. Okay, good.
Yeah, thank you. Sorry, I had to mute all because of the background noise that's coming from one of the participants. Sorry. So you can go ahead.
Okay. So we have actually done something on that. From the code, we have something that we'll be doing again on logistic, because we've just dealt with an example of something that is linear. So you would see it, we'll walk through them. But one of the major thing again that we would also need to understand is the concept. Let me show you that question to tell you why this particular thing is very important. Let me show you what I'm saying. Because the essence of some of these tutorials is to tell you
Okay,
that.
sorry, can I come in?
Please
Sorry,
come
can
in.
I come in at this point? Okay.
Come in.
I think our participants are actually getting a lot from today's webinar. So I don't know if we can ask or request that should we extend this to 1, so that I know you still have a lot to run in the script that you have for us. Would they want us to extend it till 1 p.m. or would you be able to take that long so that you can finish taking us through the script? I don't know.
Let's hear from them.
Okay.
Yeah, please go ahead.
Okay. Okay.
Okay.
Okay. So I will indulge. I will really. Okay. So at this point, I want to indulge our teacher because he's really taking his time to make us to understand this. So I will indulge that. Can we just maybe follow the script so that they get a complete overview of data analysis using the R.
Okay. Okay, that's beautiful. That's beautiful. So we just follow the script. I'm looking at an example I can show us to tell us how important this whole thing is. Please give me a minute. I need to show us this. Mid-semester. So data science. All right. I can't find that example. Let's just work with the script that we have because of our time. So we are going to start with visualizing. I did this, I don't know, I did an example of how you can, but this is a bit advanced, how you can do some few things around your console output. But let's run through it. So you do that with a package.
Sorry, I want to request that maybe we can kind of shrink the window for the environment so that we can see the code very well. Okay. Yeah.
Is it okay now, or should I just zoom it this way? Is it okay this way?
Yeah, yes.
Okay. So you see what we're learning here is I just want to how we can have some kind of good output on our console. Look at it. Let's take, for instance, we have this. We can easily say head, iris, and then we have it this way. But many times when I'm working, I always like my console output to be well designed. So I use this particular cable function from the netar, and look at what happens. Can you see it? It helps me in separating, so I can easily say, okay, this is better with, this is species, etc. Do you understand?
Please repeat what you did now.
What do you say?
Please just repeat what you just did now to separate the table.
Do you understand what you said? I should repeat that again.
You did something to separate that table now, just now.
Yes.
Okay, sorry. What he's trying to say is that using that table function, the package you just used now to display your table in a different way.
Okay. Thank you.
Yeah, exactly. Yeah.
Okay, good. Okay, that's the question he's asking. It's very simple, you know. Normally, this is the default way is going to bring it out, but you can just change it with the cable function from the init package, and then it gives you that kind of demarcation. You can use this additional argument of RST, and I will explain. You see, it gives it another well-designed demarcation again. So it depends on what you really want.
Thank you.
So yes, it depends on what you really want. So, but
Okay.
it's not something
Sorry,
that.
let me add to that.
Okay.
That function, the cable function, is from the init package.
Yes.
So you have to install it before you can use it. Head function comes with the R-base package installation. So, but cable comes with the init package. Thank you.
Okay, thank you.
Okay, so a whole lot of things, but I'll just run through. I'll run away from this in our prepared, and let's just talk about data visualization. We can do this before 1 o'clock. So how do you visualize your data in such a way that a lot of information can be derived from the data? This is what we're learning here now. So the first thing is, let's just learn it on the base. Let's learn how to write this whole thing on the base. Let's learn how to write it on the base. So I have a penguin data set here. Now let's learn how to write some of these things on the base. I have trees. This trees data set, we already have it attached. Let's go back to this place. We already have the trees attached. Let's take, for instance, I want to have the histogram. We have learned scattered plot. On the base, I just have to say east. And what I do, I say volume. Can you see this?
Yes, sir.
So a lot of things can be done. A lot of other arguments can be had. So we can start by saying slab. So this slab means the label for the S axis. Do you understand? So the x-axis here is taking volume. I can say predicted volume, for instance, if that is what we have done. Okay. Now who can tell me why we have this error?
Code.
Thank you. That's how we learn. So I have the predicted volume. I can have my Y lab.
Yes.
I can let me break it down so we can see the code very well. I can have my Y lab and just say predicted volume against probabilities. I say against probabilities. If I run this, you can see it. So a lot of things can be done. I can say main. I can put the title. I can say histogram probabilities. So all these are ways at which we can do some of these things with the base functions. So what are prepared there have nothing to do with the base. This one has a lot to do with the additional package and functions we have from the dplyr package. So I have this particular data set called penguins. Let me check. Let me reset the work directory back to documents and see arrow workshop, and then data analysis, and then data. Okay, good. Back data analysis. Okay, so let me quickly set my work directory so that we can really have a good understanding of this thing. So we have document, arrow workshop, data analysis, data. Yeah, it's okay here. open. So then this one can easily work for me. So if I run this, we have started work. So what I've just done here is I have created a new variable called read, where I will store this particular data set penguins in Excel file into, and the package I'm using is the read Excel. This is the package you will need in reading Excel file into R. And what I'm doing here is I don't want to load the package. This is another way in which you can read functions from a package with this full column, 2 full columns, and then you have access to the function, including some default data set that came with that particular function. So I did it this way, and then I have the penguins data set here. So we have species, we have island, we have big length, etc. about this penguins data. So then I can get the names. We have length that one, you see, we have species, we have island. You can get the structure to be sure that some of these things are in their right classes. So, but what we're doing is just on the visualizing. You can also do them, but you don't need much of it in visualizing. There is a way you can add some kind of factor in your aesthetics. Let's move away from here. Let's load this package library, and let's load this package ggplot2. This is what we use in visualizing most times we use ggplot2, and again for interactive visualization we use plotly. So the kind of material I've prepared here is how you can use both ggplot2 and plotly together. We'll see it as we proceed. So look at it. How do we create a bar plot in our, can you see my code?
Yes.
Okay, I'm running through it now. So the first thing is we have to understand what we call the grammar of graphics. What do I call it? The grammar of graphics. So the first grammar is data. After data is what? Aesthetics. After that is what? Geometric. And then we talk about the concept of facets, coordinate, etc. Data. So what I'm saying is that if you want to create your bar plot on R using the ggplot2 package, so the function you use in doing that is ggplot. So the first argument that goes in, the first grammar is the data. What's the data? Read. This is it here. Read. How many observations? 337 observations of 7 variables. And the next thing that goes in is the aesthetics. That is, what do you want to use? The S and Y components. What do you want to use in getting the S and Y component? What values? Which of the variables? Then we say species. So this is just taking just one component, and then we'll go, what are we using? Well, the kind of geometric we are looking for is the bar plot. And say, so to do that on R is geom_bar, and then you leave it this way. Then you can run your result and you will see it over here. Can you see it?
Yes.
So how many species do we have?
3.
3 of them, thank you. Adele, Chintrap, and Gentoo. So you can check again. We have ggplot, we have read, we have this. Now, what am I trying to do here? What's the difference between 95 and 96? We're only adding color.
Hold on.
So this color is just, yes. So this color is just going to give it an outline color. When you use color, it gives it an outline color. You can put the color at the level of geo_bar. At the same time, you can come to this level of aesthetics and also do that. You understand? You can also do that. But let's run this and you see what I mean by the outline color. Can you see the outline color on it?
Yes.
Yeah.
So imagine you want to fill it. These places that are filled with arch. So what you do is to say geo_bar. Inside that particular bracket, you include the argument fill and you set it to blue. If I run it, do you see it?
Yes, sir.
So now for histogram, bar plot and box plot, we will use what? Fill instead of what? Instead of color. Can you see it? Now look at what I'm doing here. I want to fill them. I want to fill this one with red. That's the code I'm doing next. I want to fill the next one with blue and the last one with what? With green. So do you know what I will do? I'll run it again this way and say, use this, and I'll say fill, and then I specify the color. I'm not filling it with just single blue or true. I'm filling it with red, blue, and green. If I run this line of code now, look at what will happen. So that's same thing I've done. I can also do it again with this line of code that I have in line 101. So I'm saying now, give me color, fill it, but fill it on the levels of the what? Factors we have for the species. So this time around, Ari will be the one that will give it its own special color. I'm not the one that would do that. It will give it colors. Look at it based on that levels. Do you see the color it gave it?
Yes.
And then it now gives me this kind of legend outside. The factor of the species we have Adeli for this, green for chin trap, and this light blue for what again too. Do you understand? So when you look at this now, the next code I did was I don't want to see the legend. I don't want to see this legend. Then I just say ggplot, and then I just run this. So the legend is out.
Okay.
So how do I add labels like we did the other time with the base function? Very simple. Having written all your code, you just say labs, labs. You see it, you add it to the existing grammars that we have, and then you just say labs x. Don't forget to put it in code so you won't encounter the error I had the other time. So penguin species, y is number of the what? Number of species. If I run this, you see the name. Can you see it?
Yes.
So how do I add title? Very simple. I have stored everything. I have stored everything now, all to the level of the x and the y labels. I've stored them inside a variable called what? PL. Do you see it?
Yep.
So this is one of the advantage when using ggplot. Now I can easily see PL now plus what? Labs, and I put title, bar plot of what? Species. I can do it this way. Can you see the title? Or I can use this. This is the recognized one. I can say gg title and do it. I'll still get the same thing. Do you understand?
Yes.
So look at, I said I learned R many times, you know, I love it. So I learned many of the things I know myself. Now look at, how do I do that? You see this question mark, I want to learn more about geom underscore bar. Then I say question mark geom underscore bar, then I run it. So look at it, I have some descriptions and I can read a lot of documents that can help me in case I'm stuck somewhere. I can just come, I can see an example. I can copy all these things, run it and see, okay, what's the difference? You can see all these arguments. What do they mean? When you're saying data, that's the first thing, mapping, all those things. How do I do this? How do I achieve it? You can see many of them here with some examples. So we have learned something about bar plot. Let's go to histogram. So library, ggplot2 movies. Then I'm creating a variable called movies. Movies is a data set from this particular package called ggplot2 movies. So I run this. And for instance, I don't want to print that df. It's going to make our console very dirty. So I can say the column names of movies. The names are plenty. 21, 22, 23, 24 of them. We have a movie that is rated comedy, one for drama, one for document, one for romance, one for short, etc. So how do we?
When do they close?
Hello, are you asking a question? Okay, now let's talk about the histogram of ratings, continuous, one variable, data and statistics. Let's see it. So rating is one of the variable we have inside that particular data set called movies. So let's see what we can do. Getting the histogram. Now it's just one continuous variable, just like the same thing we were still dealing with for bar plot. You just have just one component. That's what we're doing. So if I run this now, let me increase this place. So you won't see any result because I store it inside what? PL, right? Are you with me?
Yes, sir.
So Control Z. Imagine I print PL. Look at what will happen. Imagine I print PL. Do you see? What do you see? Is empty. I've just prepared just two of the grammars. I've just prepared what? The data and the aesthetics, right? So what am I drawing on this aesthetics now? What am I drawing on this particular plane now? That is what you are going to add with the geometric grammar, the geometric component. So what I'm doing now is that I'm not doing bar plot, geom underscore bar. I'm doing histogram. So I'm adding it to the PL, geom underscore what? Histogram. If I run this, this is it.
Yes.
Yes, sir.
So look at, I said being width are also with rating. So look at it, I can change the beam width. I will explain all these things. I can change it. I can change the beam width. You can give it any kind of thing. I mean, that's to tell you the width at which all these beings, all these particular rectangle, their width, you can change down. You can also change the color. So look at, I have an outline color at the same time I have a fill. I told you the color will give an outline. This particular fill will give it the real color. And the alpha talks about the level of transparency. If I run this now, look at what will happen. Can you see it? So look at, you might not see it clearly. Let me zoom it. Can you see it? So
Yes.
this is the outline. We have pink as a real color. You would see that it is transparent because I can still see the underlying mark for this particular place. You understand? I can see it beneath this particular graph. It is because I set the alpha level to 0. Look at, I move away and I change the transparency now. I change the transparency to 0.4. Look at it. Do you see it? If I change the transparency to like, let's say 1 or 4, you will see what happened. Can you now see this line again behind the graph? No. Because I said I don't want it to be transparent. I've done that. So I move away from this place now and I talk about okay, it's still the same thing, the beam width and the alpha. So I move down and I talked about how do we now have the Y label and the S label. We have linked that one. So I created another one, I call it PL1. You see it, I don't want the code to be long. That's why I'm creating them and storing them in an object. It's possible with ggplot too. So I just do it this way. I run this and then I come here, I put the S lab instead of count and this rating now. And then I print my PL2. What do you see? Movie ratings against what? Against count. Do you understand? So I can put my GG title where I've linked that one and then I have it in my graph or graph of movie ratings. I can change it. I can call it graph of movies rating. So that's all about that. So we can come again and look at what is going on here. I'm saying using aesthetics. You can use aesthetics. All these things we have learned them. We have learned them. Yes, we have learned this one. You could see. So I said aesthetics. Fill it with the cant. Fill at least the color. Fill it with the cant, and then you begin to have it this way. So places where we have high cant, it will be light. Places where we have low cant, this is it will be having this deep color. But in many of those cases, we have high cant. That's why we have it as this light. And I also set the transparency to be what? 0.4. Imagine I set the 0. Let me set the 0 transparency to 1 and see what will happen. Okay, good. So you could see in this place, we have, this is where we have the count of the ratings. It is low here. Where we have it thick like this, the count is 500. When we have it as 1,500, it gets so light. That's what this particular legend is telling us. So you can remove the legend using that show.legend and you can turn it either to true or you can turn it to false. So you can add the title to it again in this manner. And so we have learned scattered plots using the base function. But have we learned it using what's this thing? Using the default. Okay, we have, somebody said it can be zoomed. Are we following?
Yes, sir.
Okay. Let's learn. We are playing scattered plot using the base what? Scattered plot the other time when I was trying to explain one of the analysis we did, the modeling part of it. So we did that using the base function. Now let's learn how we can do it using this additional package we're using now, the ggplot. Can we proceed? Hello, can we proceed?
We're
Proceed,
good
sir.
to go.
Yes, we
Yeah.
can proceed.
So
Yes.
we have df to be empty cars.
Okay, I think we're all with you.
Okay, so we have df to be empty cars, and then we say we're familiar with empty cars. So I store this into PL. So imagine I run PL like I told you. What I'm just doing is I'm just trying to prepare my plane. I'm preparing the plane where I'm going to draw whatever I want to draw. So the geometric I'm putting now is the geom underscore point. So you can have it this way. So this is scattered plot for WT and MPG. You could see that there is a correlation, but this correlation is it positive or negative? So that's a question for another day. So then we move away from there, and then we'll go to this particular place. Do you see there's an argument now I'm putting inside that geom underscore point? Do you see size equals 1? That tells you that how do I want the size of those points? How do I want it to look like? If I run it, look at it. 1, it is small. So imagine I now say alpha. You know, alpha means transparency with this particular function. So if I run this now, look at it. I change the size to what? What's the size? 5.
5.
What's the alpha level? Transparency level? 0.5.
5.
So this size means how big do you want it? It depends on what you want to do. So I can say 10. Can you see it?
Can see.
So a lot of things that you can do without. I remember when I was in GSS 3, there is a particular math question that when we're dealing with coordinates, you can use that coordinate to draw the head of a horse. A lot of things can be done with this kind of concept too in R. So, but let's just proceed. So we say the highest function can also be passed into the geom. I've said this earlier, that inside that geometric component, we can also pass the aesthetic function. And look at this, it PL underscore this, we have that. And we're saying, say, come on, make the size the way the horsepower is. So where we have smaller size, we have small horsepower. Where we have big size, we have big horsepower. A lot of ways in which you can use graphs to give out some very relevant information. You can also see it, let the size be with the level of the cylinder. And now 4, 5, 6, 7, 8 like that. So the cylinder does not have anything like 7. It doesn't have anything like 5. So you can say size in this place now. Most times, what one will always do is to say factor, and you will see maybe to work or to give some kind of error terms. So let's see what's going on. Because definitely this way it is meant to be. This is the way it's meant to be. So let me take it back to what it is. Okay, good. And then let's go. Look at what I said. I said it becomes different here. R assumes CYL as what? As a continuous variable. That's why we have 5, 7, which initially was not in the data. Now, to ensure that it has those unique values, that's what I just did. We use the factor function, and then it changes it into the way it's meant to be. So we have the shape. You can treat this one. You can say, okay, see, I want to represent each of those things that belongs to each of those cylinders with different shapes. This circle is for cylinders that are 4. Anyway, we have cylinders for information on cylinders, where cylinders is 4. Here is this triangle is for cylinder 6, and this particular square is for cylinder 8. So you can, a lot of information you can derive from this. These are how you can do them. So we have learned about size. Imagine I run this, we have learned about size. How big do you want it to be? So you can easily see it. Where we have square, where we have circle, and where we have triangle. So I can also do this again and look at what will happen. I can change the color. We have learned this, right? Hello, are we together?
Yes,
Yes,
sir, we are together.
Okay, so I would move away from this concept of best color. It's more of graphics, but I provided a website where one can go and learn. So all these are still ways in which you can still get something from your scattered plot. Let's learn about pie chart. So you see what is in my pie chart. What I'm just doing, there is no much thing I'm doing. I'm just adding more arguments that will turn it from the way it was in a bar way and turn it into something that is pi. I just run through this, for instance. Okay, let me remove this team because I still don't have, I'm yet to load DigiTeams. Okay, let's load it once and for all. Library. There is a way you can change your teams. You see, library, my DigiTeams. So I have this. So if I run this whole line of code now, let me run it to this point. So can you see my pie chart?
Yes.
Okay, so if I zoom it,
Yes.
you can have it this way. So if I run it to this particular point where I have all these things, you would see what I'm saying. So this is it. The theme is void. I don't want anything. It's just void, like blank. So there is a way you can do that. You can provide some other things. So you can add labels, as we have learned before. You can do it using that particular thing. So we have loaded this already. So let's learn box plots. The other time when we did our descriptive analysis, we didn't talk about this box plot, but it's very important. Some of those 5 number summary that we have, the mean, the maximum, the minimum, the first quartile, the second quartile, all those things are what we have on our box plot. Let's see what box plot is all about, because I know I've been in many classes where I would just be assuming people already know box plot. And sometimes I want to jump away from it and somebody say, I don't know it. And of a truth, some people have not seen it once. As I want to assume that we have some people that don't really know how to explain the box plot. This is it. And then let's go with it. So this an example of a typical box plot. Now the way it is, I can change the theme. I can say plus themes underscore base. I can use the base theme and run this. Do you see that is quite different? I can say theme underscore economics and then run this. Do you see that is quite different too? So what we have here is the minimum value. What we have on top is the maximum. These are just, like I told you, we have an outlier in that particular data set. So this is the first quartile. This is the third quartile. And what we have here is the median. So that's what a typical box plot explains to us. So let's proceed. So imagine I have PL, and then I say print PL plus geom underscore plot. Can you see it now? So I'm not just doing it for one thing, I'm doing it for both 2 components, for the cylinder and the miles per gallon, all at the same time. So I said, okay, where we have cylinders that is equal to 4, what information can we have about them? Now for cylinders that are equal to 4 alone, what is their median? This is what we have here. What's their first quartile? This is what we have here, below 25. What's their third quartile? A bit above 30. For this one too, how do they spread? We have the information about it here. We have that for cylinder 8. That's that with how you can use box plots to make some very good inference. And then we have this print PL plus geom underscore plot Now this one is just very simple. We are trying to like flip the coordinates. It's possible. Now look at what is going to happen. So this is it. So this one, the where we have as factor CYL before was what we have on the x-axis, but now we have flipped it. So it is now staying now on the y-axis. Sometimes we do them to really see a lot of things going on and see where this particular first quartile for vehicles with cylinders fall, where their first quartile lies and where their third quartile lies. We do it for that too. So look at what I have here. I'm giving it a color of blue. So I can change the color again based on the factor of the cylinder. And then I can also do this. That's talking about the usage of this base, these themes coming from the GG themes package. So you can use this theme underscore dark. I can choose to use theme underscore base. And you'd also see, so I can use this. Now I told us, I said we can remove the legend. Do you still remember?
Yes.
You can remove the legend and just come to so you just keep it inside that particular geometric and you say, I don't want to see the legend. So that one is possible. Do you understand?
Yes, sir.
Okay, so we move away from here. We will not talk about coordinates, facet grids, themes. This is where I will stop with data visualization. Let's just learn how you can come up with some kind of interactive visualization plot using Plotly. So I know some of us don't have this particular package. If you want to check, maybe you have a package or not, you can just come here. You can check, just spell it. If it doesn't bring it out for you, that shows you don't have it. So I have my own Plotly. So I don't need to be saying install this Plotly. I just do this library. I already have ggplot2 installed. I just run my Plotly. So look at what is going on here. What are we doing? We are building a scattered plot with this particular argument that we have as geom underscore point. You know, geom underscore point is for scattered plots. Geom underscore bar is for bar plot. Geom underscore histogram is for histogram, right?
Yep.
So then I run this whole thing. Look at it. I'm just trying to tell you the relationship, how you can relate Plotly and ggplot2, the relationship between these two things. I use team underscore economist, and then I come here, look at it, and I say ggplotly, and I put the entire thing that I have. Look at what is going to happen, and I say print GPL. Look at what will happen here. The interface will change. Do you see that the interface has changed? As I'm moving around now, you can see it's telling me information about it, which is not there here. Let's go back to this place. Now, when the Plotly is still activated. Okay, I've deactivated it. Do you see now when I brought my cursor to this point, does it give me any information?
No.
No. So to have that kind of interactive feel, you use the ggplotly and then you run it. So you can move around, you can do anything, you can zoom. These are some of the options you have. The lasso select, you can select, you can even snap and store it as PNG. You can change, I can change the theme. I was going to put this economist theme, you can see. Now over here, look at, this is when we have weight to be 5.2 and we have MPG to be 10.4. Here we have weight to be 5.0 and we have MPG to be 14.7, etc. So you see, produce with ggplotly. I can come here, look at it. I can zoom it, you see it. Imagine I want to see more information about this, I can zoom it and see it. Do you understand? Any question? And then I bring it back. So ask your question.
I ask a question?
Yes, ask a question. We are done with the whole
Okay.
thing. This is 8
Alright.
minutes to go.
Okay, is there, can this plotly be embedded into a document? The plotly,
Can it be what?
embedded into a document?
Yes, that's why you saw the snap. But when it gets to a document, the interactive part of it stops. It is
Okay,
only,
alright.
yes, the interactive part of it stops. If you are developing a website, you can incorporate it. Probably you are using Arrow for your website. You can use this. And I know the coordinator of this training is very good with some of these things. Is very good with this particular one. And there is yes, there is one. I'm trying to remember. She's just very good with that one, Sha. So with all this dashboard, flares, also of things, she's very good, and you can use.
Are you talking about Shiny?
Yeah, good. I'm talking about Shiny. So she's very good at that. So you can also incorporate some of these things to make your work very neat and beautiful. So at this point, I would just love to put an end to it. It's almost 1 o'clock, so I can go ahead. I know I was too fast. Am I too fast?
I will want them to respond to that. You're
too fast?
You're not.
No, I think it was just perfect. It was okay. Excellent. Thank you very much, sir.
Awesome.
Thank God.
So, okay. I think you've really tried, because I wasn't even expecting you to stay this long, because when we were discussing our planning this program, you requested that you wanted to just 1.5 hours. That was what I was looking at.
Yes.
But I'm really happy that you really stayed this long, and it shows that you're a real teacher. You can manage your time and you can live up to expectations even when you get the surprises. So you've really done a good job, and I think for those who are just coming up, you've really dealt with all the fears. And with somebody making a comment in the chat box that R is beautiful. Yeah, R is beautiful. Simple. I can say that anyway. R is beautiful and simple to learn. The learning curve might be, they might say, okay, it's scary or something. No, but if you give it the time, you have to make a commitment. There's nothing that you want to achieve that you don't have to commit your time and energy into it. This helps you to build your passion for it. So that's just what I will say in rounding up on this program today. Joshua, I'm really grateful. Based on our discussion, you really helped with this webinar. And I believe those who are just coming up and those who are also joining us from around the world, they've learned a lot today. I've learned some things that I don't usually use. So I'm so comfortable with tidyverse, but using the basics, the base R functions, I'm so happy. You bring back memories of how one started and getting to be using packages that makes your work much easier and even smoother. That's a plus on this webinar. I'm really grateful and I really appreciate your time. I think, does anybody has a question or comments you want to add to it before we round up? Hello? Do we have comments? Okay, there's somebody else. Okay. You know what? Okay, the question says, please, where does show legend belong to on the ggplot2 layers? Okay. I think we'll have to discuss outside of this webinar. We would okay, let me just share the meetup page then. So just hold on, join the group, then maybe we can share our WhatsApp group as well with you so that we can communicate outside this, outside the webinar. So that's what I would just request of you now. So let me just bring up the Abuja R user group meetup, then I'll share it with you.
So can I ask you guys a question?
Okay, go ahead.
So I see a lot of time when we go through this training, like how to use R, Python, and all of that. But my question will be, how much statistics needs to come in first before these tools become very useful to one?
Okay, Joshua, do you want to answer that?
Okay, very good question. Very good question. And when I started, I gave a short story as to my background from forestry, and then people often ask me that question: what are you doing with R? So one thing I've learned so far is this: for you to have a good understanding of this particular thing, there is no how. You have to master a bit of statistics. You have to master a bit, because majorly what we are doing, modeling, there are some kind of things that were coined out of statistics. So for you to really have a good understanding of some of these things, you have to have that understanding of statistics. Like the other time when we're talking about correlation, when we're saying, okay, this one has greater impact on this one, the strength of this against this, all those things are not political science, are knowledge I learned from statistics. So a lot of statistics will be put into it if you want to go deeper. Like now, there are some things I'm doing that will require me on an advanced level to go and read some advanced statistical test. So I would say if you want to go higher, you will need more of it. Thank you.
Yeah, thanks.
Okay, he has really given a simple answer to that. You need statistics to get to understand. If you're hearing, okay, you need to understand machine learning, you need to know math. The beauty underneath, what is hiding behind all this, all the jargons and the big words that you might be hearing, it's about statistics. You need that understanding, and I can bear it with you. Just give it some time. I'll post in a link here. You can start and you can go, just use YouTube well. There are basic statistics, the lessons that people have really gone ahead to do a good job about it. So you can learn that, but that should not scare you away from learning R. While your R is basically the foundation for R programming language is about statistics. R was created for statistical models. So anyhow that you're learning R, you are also learning statistics. So don't get scared that, okay, all these things, how would I understand it? No, you've done a lot of statistics today. And he has really used simple words, simple examples to make you to understand it. And I believe if you have to watch this video again, you would be able to continue. So any other question? Comments? Okay. Okay.
I have a question.
Okay, go ahead. So that it's past one now. So.
Is there some kind of would I call it a forum or platform whereby attendees can interact maybe on a regular basis apart from just
sure. Sure. Let me get the WhatsApp group. Maybe you'll be able to join us on that. Let me give the WhatsApp. Are you based in Abuja?
I'm based in Abuja.
Okay, good. So I will share the WhatsApp. Let me just bring it up on my laptop. So the invite link. Okay, let's copy the link now. So for those who are looking at joining for ladies, I think this is the ladies first. Okay, for the ladies group. Then sorry, I'm just have to work in between the two. Okay. 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 invite and copy the link. So this is the second link for those who want to join the Abuja R user group for both groups. But basically what we're just looking at is to make life easy. If you don't want to join the mixed group, you can join the R ladies group to create a platform for those underrepresented within the community. So that's that. And I've shared the link for our meetup group on platform online. Then you can also check us up on LinkedIn. Okay, let me just quickly do that. Now for LinkedIn, the Abuja R user group now, then the R ladies. So for the R ladies, just search for R ladies Abuja. R ladies Abuja. It's okay, Abuja. So on LinkedIn, that's for LinkedIn. So that the Abuja R user group is a group on LinkedIn, not a particular account. So it's a group. So I will share the link as well now. So this is the link. So these are the various platforms. Since Twitter has been blocked here, I wouldn't think it makes sense to share the Twitter accounts now. So till when we have it released, then we'll be able to share the that will be the Twitter handle. So for now, I think we can still talk so much using the WhatsApp, the LinkedIn, and the Meetup page. So that's enough for us to communicate. So you can also direct your questions anytime. We would be available, try as much as possible to help each other out. That's what we want, and that's the same mission that we're all on. So I am really grateful to you once again, Joshua. And at this point, I want us all to help me say a big thank you to Joshua for his time. So he has really done a really good job.
Mr.
Yeah.
Mr. Joshua, thank you so much.
Thank you, sir.
So thank you so much. Thank you. So thanks so much. I'm really grateful. So at this point, everybody, you keep on learning R, and we'll see you the next time on our webinar. We're looking forward to getting another teacher to take us through machine learning. So don't get scared. We're going to break it down. We're going to break it down. We can even use R for AI now. You said, somebody said something?
I said, please remember to send us the material.
Okay, I will share it. Just make sure you get all this link together. Take all the links, please. That's the easiest way to share the information. Please.
Please, can you return the link?
Okay, good. Okay, I'll try.
Not signing out automatically. I don't know what happened.
Okay, I'll copy again. Let me see if I can. Okay. Okay, that's coming in again.
I belong to this place.
Okay, please just click on the links and just sign up or sign now. Okay, for the Abuja group, just join through this. So the WhatsApp group. Okay, the WhatsApp group, I will share that now. Okay, copy and paste. Okay. Okay, there's another one that I'll have to copy. Okay. So for the ladies and for the male, so just say hello and just introduce yourself on the WhatsApp group. So then I'll be able to redirect you, because I think there's a mix up in the WhatsApp group, so I don't know which is which now. So just try and log in. If you don't belong to the R ladies, I'll take you out and I'll redirect you to the R user group. So So thank you so much, everybody. Thank you. I really had a long time and it was interesting. I think it's same thing on your side there because I wasn't even looking at this at all. So thank you so much for everybody that joined us today, taking their time, and especially Joshua, I'm really grateful. Thank you so much. So we look forward to having a good time together and much more collaboration in future. Thank you so much and God bless you. So we'll share the video and everything online.